Michael, can you perhaps tell us a little bit about shortwave infrared? Where does it come from? When did you first hear of it, and why is it interesting?
Yeah, when I came to Kowa, I never had contact with the SWIR cameras and SWIR lenses before, and I saw them in our product range and was very curious about what is the difference between visible and NIR and SWIR. And then I studied that, how it works, what is the difference, and I found it's a very interesting topic, and the effects are not known by the users. Even professional users, they don't have so much contact with this technology. So I prepared that and broadcasted this in my business trips and in talks. And this zoom lens, for example, that is a product I have generated on my own. This lens is existing as a lens for standard CCTV cameras for visible light. And this lens can also be used as a SWIR lens because of the coating. But your special technology, SWIR sensor, it's a SWIR sensor. So it accepts visible light. It can make signal out of that and also sees the wavelengths beyond IR SWIR. So we have here a filter wheel. It has a transparent filter as seen on the screen. So if there's a low light application, so low light that nothing makes a picture, then we can gather all what is available to get a picture where you can at least orientate. But if you want to study where's the laser coming from, and you see other light sources which maybe influence where's the laser, what else is a laser, what else is maybe an IR or a SWIR reflection, then you can switch to a filter to cut away the visible light. Now it's a 920 nanometer filter, and you can see every artificial light is off and only the laser is very clearly seen because the transmission of this filter is almost 100% for SWIR and nothing for the visible light. So it separates the wavelengths. And I can go even ahead on 1000 nanometer to even more separate. It's 1000 nanometer, and still you see no artificial light. Clearly you can see the laser. And then I go on 1475, and then the AGC of the camera is enhancing the picture so much that you can see the temperature of the lamps already as a new light source, because the lamps, it's not the light which is coming out of the LEDs, it's a temperature which causes the light here. So that is something which you can detect with this kind of technology. So very, very different.
So SWIR can be used for doing temperature measurements as long as the temperature is high enough.
Exactly. Starting from 200 degrees, it starts to shine on its own. Yeah. And what you else can see, I have we made that at home, you remember?
Yes.
It was that flame on the table. We had this ethanol flame burning, and you can see, you can't see that the flame is burning because this is almost invisible. For the human eye, for cameras, for visible light. And what you can see is you can clearly see the shape of the flame with SWIR. It is 100% contrast. The shape of the flame, because of its temperature, of its own temperature, is completely visible. While a thermal camera can see the flame as, let's say, 1% contrast only. It's a very big difference between
In contrast.
in contrast if you use SWIR or thermal cameras.